Okay, in this video, we're going to do the review for 4.1 to 4.3, and we'll have a quiz on this next class. So the first thing they asked us to do is evaluate exponential functions using a calculator, so I highlighted that, and round your answers to 3 decimal places. So here's your function right here, and the f of 1/2, you would put a 5 for your base and raise it to the 1/2 power and evaluate that. So let me do that. And 3 decimal points, I get 2.236. Make sure you can get it. This you would take 5 to the pi. And if I do that and I raise 5 to the pi, notice where the pi key is, right below the clear key. And I'm going to get 156.993. Make sure you're getting these. Then if I take 5 to the -3, raised to the -3, you should be getting 0.008. And the last one is 5 raised to the e. So 5 raised to the e. So that's above the ln key. Got to say 5 raised. Let's clear that first. Okay, 5 raised, and then you're going to say second ln, and then put that to the first power and hit enter. And you should be getting 79.432. So what I actually did was that. So make sure that you can get these answers, okay? That's 5 to the 1/2, 5 to the pi, 5 to the -3, and 5 to the e to the first. Okay, so there you have it. First question's done. Okay, next one. Find the solution to exponential equations using the uniqueness property. So what that means is you get the same base. Same base. And then once you do that, you're going to set your exponents equal. And then you're going to solve. So those are your steps. Okay, so this one, very first one, number 2. What I would do is I would say this is x minus 2, and common bases, remember common bases are 2, 3, 4, and 5. So raise 5 to the third, and you'll get 125. So next, you want to say, if the bases are the same, that's unique base, that equals 3. So add 2 to both sides, and I'm getting x equals 5. So that's my answer for the second one. Okay, I'm going to change color to get you a little contrast. All right, another common base, as I said, is 3. So 3 to the 4x minus 1 equals 3 to the third. So then when you have the bases the same, you can set your exponents equal. Plus 1 gives me 4x equals 4. So therefore, x is going to be 4 over 4, or 1. Okay, so that's all set. Next one, I would go for the same base. So I'm going to first do this maneuver. This is 4 to the -1 raised to the 2x. So that's 4 to the -2x. That's going to equal 4 to the third is what 64 equals. So -2x equals 3. So this is -2x equals 3. So x equals -3/2. Okay, we have one more of these left. That's this one. So I'm just going to move this over here. And first thing I'm going to do is bring up that e to the third into the numerator. And to do that, I have to make it e to the -3rd. Bases are the same, so 7x equals -3, x equals -3/7, and we are done. Okay, so there you have it. All right, next thing. They're just saying for this to express for equations in exponential form. So these are in log forms. So to change it to exponential form, find your base. So for A, my base is 5. Logs equal exponents. So my exponent is -1. And this equals 1/5. And I'm done. Okay, I don't need to do anything else other than to express it in exponential form. Next one, my base is 4. Logs equals exponents. 3 is the exponent, and that has to equal 64. Okay, there's nothing to solve here. You're just rearranging. And you should see that these terms are indeed equal to each other. Get your base. Remember, logs equal exponents, and set it up. Okay, get your base. Logs equal exponents, and that's going to equal whatever z is. Z is, I guess, 6. And then get your base. Logs equal exponents equals 3. And that's all you have to do for that. Okay, I'm going to have you continue doing that. But now we're going to do the reverse. So we're not solving for anything. We're just expressing equations in opposite forms. Okay, 9 and 10 are expressed in exponential form. You're going to write it in log form. Okay, so let's start doing some of those. So for 9a, I say, okay, what's my base? My base is base 4. Logs equal exponents. So the exponent was -3/2. And then this is your argument right here. Done. Okay, this is log base 7. Logs equal exponents. That's your exponent. And then put your argument right there. Okay, this is base 3. So log base 3, logs equal exponents. And my 10 goes right there. Again, I'm not solving. I'm just rewriting the form. Okay, this is base 10, so I don't write that. I just write log only. Log equals exponents. This is my exponent, and my argument goes right there. Okay, done. So we've got those are just rewritten from exponential form to log form. Okay, now they want us to evaluate without using a calculator. So I say hint, set equal to x, rewrite in log form, and solve. Okay, I'm not going to give you that hint on the quiz, so you have to know how to do that. So first thing I'm going to do for every single one of these is set it equal to x, and I recommend you do the same thing. Now in this situation, we have to solve for x because that is how we're going to evaluate this. So let's change the form. They're all in log form. I'm going to be able to evaluate it by changing it to exponential form. Okay, my base is 3. Logs equal exponents. That's my exponent. And then that has to equal the argument. And that, therefore, I can see using unique base that x equals 7. And that one's done. Okay, look at this next one. Find your base. It's 4. Logs equal exponents. There's your exponent. Now, I'm not going to be able to see the answer unless I change this argument, which is 64, to 4 to the 3rd. That's going to give me that. Done. Okay, next one. The base is 5. Logs equal exponents. 5 to the x equals the argument. I'm not going to be able to see the answer unless I change that argument to 5 to the 3rd. So you have to know how to do that and get comfortable with your exponents and bases. Okay, we have a couple more to do. Let's do 12a. And here's your base is 2. 2 to the x equals, and this is 2 to the 5th, I believe. Right? Check that. Okay, 2 to the 5th. Bingo, 32. So therefore, x equals 5. Done. Okay, so this is 8 to the x equals 8 to the 17. Therefore, x must equal 17. That's done. Okay, this next one, your base is 6. Logs equal exponents. That's your exponent. That has to equal 1. Now, here's when you have to remember something. Any base raised to the 0 power is 1. So that's going to let me see that x equals 0. And now I am done. Okay, you definitely want to know this. You want to know that equals 1. Okay, so now this says, evaluate the following expressions using your calculator and rounding to 4 decimal places. So you can use just a regular calculator because this is base 10, this is base 10, and this is base E. So I'm good to go with my regular calculator. I need 4 decimal points, so therefore my mode is now going to equal 4. On my calculator, I changed my mode from the 3 that I had previously to a 4. So that's all set. So now I'm going to take the log, I see what my log key is, of 2.3, and I should be getting, or you should be getting, 36.17. Then take the log, carefully, of 2, and then times second radical 3. Close your parens, and you should get 0.5396. Okay, now you're going to take the ln of 7.2, and that's going to give you 1.9741. Done. Okay, find the domain of the function. Okay, so there's a hint. I'm not going to give you this hint on the quiz, so you definitely want to know that. Take your argument and make sure that that is greater than 0. That happens where x is greater than 4, and so using interval notation, what you're going to see is that you're going to start at 4 and go to infinity. Okay, so if you think about that as a line, the argument looks like this. It's a line that starts at -4, 2, 3, 4, and goes up by 1. Right? 1, 2, 3, 4. So what's going to happen is your line is like this. Okay, this is what the argument looks like. So the way I got my answer was to make sure that that argument had to be greater than 0. So that's where that happens. This is 4, and this is going on to infinity. So that is my interval notation expressing the domain of this function. So those are what the x's can equal to be a legitimate log term. Okay, next one. Natural log of 2x plus 5. So if I have that, I'm going to do the same general approach. I'm going to set 2x plus 5 has to be greater than 0. So 2x is greater than -5. X is greater than -5 halves. So that means I start at -5 halves and I go to infinity. Okay, this is also a line. I could do the same analysis I just did on this one. Plot your line. In this situation, your slope is 2, so let's quickly do that. So I have my line here. Okay, so if my line is y equals 2x plus 5, I'm going to be over here at 5, right? 1, 2, 3, 4, 5. My slope is 2. So if I want to trace out this line, I can go down 2 and over 1. That's another point. And then go down 2 and over 1. That's another point. And I'm going to be crossing the x-axis right about here. So here is that argument. And where am I allowed to use values from? All along this yellow. And that's how I got the interval that I had for my answer. Okay, so here are your 2 answers with a very thorough explanation as to how I got them. Okay, this is interesting ones. Find the inverse of the exponential function. So remember how we did this. We first switched your x and y. Okay, and then we had to solve for the new y. So how am I going to do that? This is written in exponential form. So what's your base? So I'm going to say log of 6. Logs equal exponents. What's the exponent? That's the y, which is the new y. Here's the argument. So to write the inverse, use your inverse notation for that y. And it is log base 6 of x. And that is my inverse. Okay, next one. Also, change this up. Okay, right now it's an exponential form. So put it in log form. So I write the word log. I see my base is x. So, excuse me, let me go back one step. Let me switch these up. So x equals 8 to the y minus 7. Okay, now change the form. So I'm going to say log base 8. Logs equal exponents. That's going to be y minus 7. And I have my argument right here. So my goal is to get y by itself. So I'm going to say log base 8 of x plus 7 equals y. Change the notation to inverse notation. And you have log base 8 of x plus 7 is your inverse of y equals 8 to the x minus 7 power. Okay, so that's it. So here is the key, and everything's matching. So you can listen to this video again if you want to and stop it and see if you can fill in these answers. But if you can do these kind of problems, then you should be good to go on the quiz.